Okay.
Now let us look at the construction steps or the operations. What you are seeing here are the steps of the construction. One, step number one, cleaning of the existing surface. Second operation is preparation of the, once you clean the surface, preparation of the receiving layer. That means any distress in the existing layer, receiving layer, on which you are putting the bituminous layer, is to be rectified. The third step is interface treatment. That means you have to give some treatment between the existing layer and the new layer which you are going to construct. What we say, the prime code, the tag code, all comes under this category. The fourth operation is preparation of the mix, the transportation of the mix to the job site from the plant, and then paving, then rolling, and then checking for surface finish or quality control test during the construction operation. If you can see this, you can, all these operations you can see pictorially in this diagram. I don't know whether it is visible or not, but you can see cleaning, then frame coat or tack coat, then the paving operation, and then the rolling. Now look at the first construction operation, cleaning. Surface on which the bituminous work is to be laid shall be cleaned of all loose and extraneous matter by means of a mechanical broom and air jet. This is very important. The equipment for applying a high pressure air jet from a compressor to remove dust or loose matter shall be available full time at the site. This is also very important. So the surface is to be cleaned, number one. Number two, it should be cleaned using air jet and compressor. And these equipment, the cleaning equipment, all the time should be available in the job site. So once you clean the surface, the next operation is preparation of the receiving layer, existing layer. So what do we do here? We remove all loose material, dust of the existing surface, and carefully we compact of the layers, any loose layers, loose materials, and then if there are any potholes are there, we are going to patch them. If there are any cracks in the receiving layer, we are going to seal them. So all these operations we do in the preparation of receiving surface. So there are this preparation of the receiving surface is different depending upon what type of surface, on what type of surface that we are constructing the asphalt layer. Let's say there is a granular surface, wet mix macadam surface, say. So, and we are going to construct a binder layer like BBM or so on this wet mix macadam layer. Then how should we prepare this wet mix macadam layer? That is what the preparing existing granular surface. All the loose materials shall be removed and surface is slightly watered, where profile corrective course is to be provided as a separate layer, where PCC of bituminous material is to be laid over the existing granular surface. All loose materials be removed and primed. The surface of granular layer on which bituminous layer to be placed shall be free from dust. Dust to be removed from the air jet after cleaning the surface shall be corrected to the required profile, line and grade. So many times we have to prepare the receiving surface maybe by scarifying the existing bituminous layer. In that case, where this scarification is specified for the existing bituminous layer, this the layer shall be removed without causing undue disturbance to the underlying layer. That is important. And in the name of scarification, we should not disturb the layers below. So after removal of the loose layer, loose material, underlying layer be reworked, supplementing with suitable fresh aggregates and compacted to required profile. So many times it so happens that we need to construct profile correction course before constructing the bituminous layer to have required profile. So profile corrective course for correcting the existing profile shall be led to the varying thickness because it should meet your cross profile requirements. Whenever we are constructing this profile correction course, any high spots in the existing bituminous surface shall be removed by milling machine or by any other approved method. Where maximum thickness of profile correction course is not more than 40 mm, this profile correction course shall be constructed as an integral part of overlay source. That means, let's say your profile correction course thickness is not exceeding 40 mm, then you can construct the layer, this profile correction layer as part of your overlay or the whatever your proposed bituminous layer. In other cases where it is not exceeding 40 mm, this profile correction course shall be constructed as a separate layer. Please remember, this is only for profile correction course. Intention of constructing profile correction is only to have the receiving surface or the existing surface with proper longitudinal as well as cross profile, that is camber. So the local depressions, camber and super elevations are to be corrected. Where the local sags or depressions occur in the existing layer, the specific filling operation as instructed by the engineer in charge of the project shall be followed. That is for the depressions. Here, whenever you are filling the depressions, local depressions, sags, the maximum layer thickness not to exceed 100 mm. So always the profile correction course shall be covered by designated varying course or the base course at the earliest. That is important. So what is that we have discussed so far? We have discussed the cleaning operation using compressor and air jet. Please remember, these equipment should be available all the time during the construction in the job site. Then the next step is preparation of the receiving layer or the existing layer. So any cracks need to be sealed. If there is any scarification is required, the scarification to be carried out carefully without disturbing the bottom layers. And then if there is a requirement of profile correction course or otherwise when the profile of the receiving layer is not proper, then you should go for profile correction course. Wherever this profile correction course is not more than 40 mm, then this profile correction course or the layer is constructed as part of the your proposed or designed layer or overlay. Wherever it is exceeding 40 mm, the profile correction course should be constructed as an exclusive layer. If there are, then we discussed about the sags, the depressions. So any depressions in the existing layer to be filled using appropriate the layers or the mixes, and then it should be covered with the binder layer or the base layer or the surface layer at the earliest. So that's how the second operations are carried out. Then the third operation, third construction step is interface treatment. The two important interface treatment that we carry out is prime coat and tack coat. What is this prime coat? This is spraying of the emulsion, generally emulsion or any liquid bituminous binder over the granular layers like waterbound macadam, wet mix macadam, pressure run macadam. Means to say you have constructed a bituminous granular layer already, and then above that we are planning to construct a bituminous layer. This existing granular layer first to be covered with the prime coat. This prime coat is done using the liquid bituminous binder, generally the slow setting emulsion. So why do we do this prime coating or priming? Is to plug the capillary voids in the existing surface, to coat and bond loose materials of this granular surface, and to get a hard and tough surface to promote the adhesion between the existing granular layer and the new bituminous layer. These are the purpose of priming. So this priming or the prime coat shall be carried out using cationic emulsion of SS1 slow setting 1 grade conforming to IS 8887, or the priming can also be done using medium curing cutback bitumen fulfilling IS 217 or as specified in the contract. The quality of this emulsion, SS1 emulsion, slow setting 1 grade emulsion, for various types of granular layers, surfaces, are as below. If the granular surface is of wet mix macadam or waterbound macadam, the rate of this coating, prime coating, is 0.7 to 1 kg per square meter. If the surface is a stabilized surface, stabilized soil base or a crusher run macadam base or cement treated base, it is not for crusher run macadam, stabilized soil bases, the rate of spray is 0.9 to 1.2 kg per square meters. Please remember, this is not CR, it is for stabilized soil bases or for any stabilized layer. So for granular layers like WMM and WBM, the rate of spray of the prime coat is 0.7 to 1 kg per square meter. If it is stabilized bases, stabilized surfaces, the coating varies from 0.9 to 1.2. How do we spray this emulsion? The primer shall be sprayed, the emulsion shall be sprayed uniformly at the specified rate, whatever that we saw in the previous table. The method of applying of this primer coat depends upon the equipment that we use, the size of the nozzles and so on. So before spraying, we should carry out the trials, spraying trials, and then we should continue with the method of or the actual spraying. No heating or dilution of the emulsion should be permitted in the name of workability or in the for any other purpose. Cutbacks may also be used for prime coat. So then the second type of interface treatment is tack coat. Why tack coat? Is to ensure the bond between the new construction and the old surface. We can use generally rapid setting emulsions are used for tack coat, but we can also use cutback, but this cutback should be restricted for the site where the temperatures are very less or sub-zero temperatures or for any emergency applications. So this is the quantities of the tack coat recommended for different types of surface. If it is a bituminous surface, the quantity of spray is 0.2 to 0.3 kg per square meter. If it is a primed granular surface, what does it mean? There is a granular surface, already prime coat is carried out, and that we are on that we are doing tack coat. Such layer, primed granular surface, the rate of spray is 0.25 to 0.3 kg per square meter. If the receiving surface is CC pavement, cement concrete pavement, then the tack coat quantity is 0.3 to 0.35 kg per square meter. The surface on which the tack coat to be applied shall be clean from dust and dirt. Before the application of tack coat, surface shall be swept clean with a mechanical broom using high pressure air jet. The rate of application of tack coat is as specified in the table shown earlier. Here also again no dilution, no heating of tack coat at the site for emulsion. If paving bitumen is used, sometimes we use that VG grade bitumen, then heating of bitumen is required, and this heating to be carried out in the boilers to achieve a viscosity of less than 2 poise so that the spraying becomes easy and smooth. Normal range of temperature spraying of the bitumen emulsion shall be 20 to 70 degrees. For cutback it is 50 to 80 degrees Celsius. So with this temperature range, when the temperature is within this range, that is 20 to 70, you can use the emulsion. If it is between 50 to 80 degree, you can use cutback for tack coat. And this is a picture showing the interface treatment. There is a sprayer, spraying, manually spraying using the jet and the compressor. Now mechanical spraying is also done, where here it is manually, the spraying is done manually, otherwise mounted sprayers are there, and the vehicle keeps moving, a sprayer is attached to that, and spraying is done mechanically, controlled spraying is done mechanically. This is a tipper loaded with bituminous mix, that is transportation of the mix. So mix is prepared in the HMP plant. The preparation of the bituminous mix in the HMP plant we have discussed. Now that mix shall be transported in the clean insulated covered vehicles. So for the inner surface of the tipper or the hauler, soap or lime water may be applied to the interior of the vehicle to prevent the sticking of the bitumen to the interior surface, and it also facilitates easy discharge from tipper to the paver, easy discharge of bituminous mix. So a picture showing tarping of the asphalt mix so that the temperature as well as the quality of the mix is maintained if it is covered with tarpaulin. This the picture showing a tipper with bituminous mix has arrived in the job site, and paver, a sensor paver is there ready for paving. So the paving or spreading. Prior to the spreading of the mix, the base shall be prepared, except in the areas where paver cannot get access. Bituminous materials shall be paved, leveled and tamped by self-profiled paving machine. Material shall be supplied continuously to the paver and led without delay. Rate of delivery of the material to the paver shall be regulated to enable the paver to operate continuously. The travel rate of the paving machine shall be adjusted to ensure a even and uniform flow of the bituminous mix across the screed and free from dragging and segregation of the material at the time of paving. In case of restricted areas where paver cannot be used, material shall be spread, raked, leveled using a suitable hand tools by trained staff. Bituminous material with a temperature greater than 145 degrees centigrade shall not be laid on the bridge deck waterproofing systems unless precautions against the damage is taken. The tipper showing the unloading operations. A paver showing paver. Tipper is unloading the material onto the paver hopper, and the paver is spreading the material. This is another view of paving. The material is spread across the width of the screed, and this figure showing the components of the paver. This we have already discussed. And as I said, at the time of paving, constant head of materials is to be maintained in front of the screen to have a uniform, smooth profile. If the head of material is high, then the thickness varies. Generally, thickness increases. We will not get the uniform thickness. When the material, head of material is too low, the thickness reduces as paver moves forward, again giving a non-uniform profile and non-uniform thickness. So, maintaining a constant head, a uniform head of material front of the screed is important for uniform thickness, good profile. So that's what. If constant head is maintained, we get a uniform layer. If the material is more in front of the auger, we get undulated a hump. If the material is less, then thickness reduces. So that's making the layer non-uniform. So this picture indicates that at the time of paving, no rest. So paving is a continuous operation. Unless otherwise, it is very much required to stop. Paver not to be stopped. Paving is a continuous operation. Another important requirement at the time of spreading or paving is there should not be too many people. That may spoil the quality of the layer. So once the material is paved, the next construction operation is compaction. Why compaction of the bituminous layer? It improves the stability, it improves resistance to permanent deformation, it reduces the moisture penetration, it improves the fatigue performance, compaction reduces low temperature cracking potentials. So this rollers can be used: static steel wheel roller, pneumatic roller, vibratory rollers are used for compacting the bituminous layers. This we have discussed. A static roller was the compaction efficiency depends on the gross weight of the roller and the speed of the roller, thickness of the layer, and then temperature of the layer. So this is a picture showing a roller, a tandem roller or asphaltic compactor. That means if we have two steel drums, it is used as a asphalt roller. So these rollers can also be, as I said, these rollers can also be used as vibratory rollers when the machine is operated in the vibratory mode. So pneumatic rollers are used for compacting the layers. The efficiency, the compaction of pneumatic rollers depends on the gross weight of the compactor, the inflation pressure of the wheels, and also the tire contact areas. So the pneumatic rollers does the compaction by kneading actions, and vibratory rollers are used for compacting the bituminous layers. The compaction of the vibratory rollers depends on the gross weight of the vibratory roller, the amplitude at which the machine is operated, the frequency of the vibrations, and the operation skill. So amplitude is the gap of the vibratory wheel from the surface, or the height to which the steel drum rises from the existing surface is amplitude. So when mix is too hot, the mix moves around the wheels of the roller. Should remember, construction of joints is very important. We get transverse joints and longitudinal joints. To take the transverse construction, the joint should be preferably vertical. We need to stagger this transverse joints at least by 2 meters, and before starting the paving we need to spray the bitumen at the vertical face, and even we have to heat the screed of the paver. So when it comes to the longitudinal joints, Always this longitudinal joint should not be located on the same line. At least there should be 150 mm of offset. Preferably the joint should have a vertical face, and whenever or during the paving, a overlap of 25 to 50 mm with the previously laid surface is to be maintained. Then how do we carry out the rolling operations? The rolling operations, the rolling of the compaction depends on the thickness, as I said, speed and length of rolling zone and how many rollers we have. What is the rolling sequence, compaction sequence? First we need to compact transverse joints, then longitudinal joints. We need to maintain a overlap of 150 to 175 mm for the longitudinal joints. Always we have to compact or roll from lower edge to higher edge. So what are the different types of rolling operations that we carry out during the construction? 3 types. 1. Breakdown rolling. 2. Intermediate rolling. 3. Final or finished rolling. First, breakdown rolling. For the first rolling pass that we carry out is called, on the newly paved surface, is called breakdown rolling. We have to use smooth wheel rollers, or otherwise a static pass is required, that is without vibration. Breakdown rolling is very important to achieve majority of the required density. Please remember, an ineffective first pass, roller pass, may make the final pass difficult to achieve. Compaction is achieved by imparting vertical movement of the mix through the roller load. There should not be any horizontal movement of the mix like that we have seen before. Whenever we are rolling, there should not be any horizontal movement like this, horizontal movement of the mix below the roller wheel. Horizontal movement will cause heaving of the material, and crawling of mixture ahead of the roller and formation of the ridges is also should not be there. When movement of the mix is observed, whatever the movement, horizontal or movement or heaving of the movement or crawling of the mix ahead of the roller, when this kind of